Russian Railways partners. Marc Hamilton, our next speaker, he heads the international developers team in NVIDIA, are responsible for AI and deep learning, professional visualization, and high-level compute. He will tell how NVIDIA ensures enterprise IA. This is an end-to-end
Welcome, everyone. I'm Marc Hamilton, Vice President of Solutions Architecture and Engineering for NVIDIA. I'm really excited to be here today with Spur at their AI Journey conference. I'm going to be talking about AI in the enterprise and how we're really at a tipping point. NVIDIA has been working with Spur for many years on their AI journey, as well as our own. And there's one thing that I love about Spur is their people. It's simply a fun company to work with. You know, we all work so hard every day that it's nice to work with great people. So let's go ahead and get started and talk about some of the things NVIDIA has been doing with our partner Spur. Most of you know NVIDIA. You may know us only as a PC gaming company, but today, NVIDIA is the leading AI company in Silicon Valley and, in fact, around the world. You're looking at our headquarters complex in Silicon Valley, California. This is a living testbed of our own AI technology. In our data center, we have over 20,000 NVIDIA GPUs working 24 hours a day to write AI software. These power robots roaming our campus, self-driving cars that we're testing in and around campus and around the world, amazing computer graphics driven by AI, and even technologies such as AI-driven healthcare for our own employees and for the people of the world. If you ever get a chance to visit California, we urge you to contact us and visit our campus, like many of the executives of Spur have done over the years. I've been proud to host Spur executives at our campus, and they've happily returned and hosted me when I've been in Moscow. It's been a great collaboration over the years. Start by showing you a little work in progress video, a home video, so to say. Now, AI started over a decade ago, was very much based on computer vision and computer vision technologies and applying AI to computer vision. So we'll go ahead and roll the video.
Put the red blocks in the green bowl.
Everything that you saw in that video was software that was written not by a human typing at a computer, but AI software written by AI software. AI is an amazing new world, and the possibilities are endless. But today, what we're doing with companies like Spur is taking AI out of the research world and moving it into the enterprise, solving real-world problems to increase productivity and make businesses better performing. There's a number of areas that drive NVIDIA's research and development. We started the company in 1993. And by 2000, we had moved from computer graphics to accelerated computing. At the time, the world was still in the era of CPU computing. But today, every single computing company in the world acknowledges that accelerated computing of one type or the other is the path forward. As I mentioned, AI is a new type of software, the right software. Computer programmer today, going to university in Moscow or around the world, isn't just learning how to write traditional computer code. They're learning how to turn data into AI software. As that happens, the computing needs grow massively. It's no longer enough just to give your developer a laptop. The data center is the new unit of computing. We've seen this for many years in the cloud service providers and their massive data centers. Enterprises have been challenged in this area, and we'll talk about how NVIDIA is helping. AI on 5G is kickstarting the fourth industrial revolution. And finally, robots will assist not only in the real world, but in virtual worlds. And NVIDIA is working across these technologies. NVIDIA doesn't just make computer chips. We're an end-to-end platform company. Of course, we make some of the world's largest, most powerful, and most complicated processors, our GPUs, our DPUs, and our CPUs. We go beyond the chips, and we build examples of some of the world's most powerful servers. Our DGX A100 systems used in the Spur Cristofari supercomputer power many of the world's enterprises in their AI pursuits. And finally, because just a single computer isn't enough, we build an entire data center or supercomputer, a full data center full of computers acting together to solve one problem. Of the 20,000 GPUs at NVIDIA's data centers, about 4,000 of them are connected together in one single supercomputer that ranks as the world's sixth fastest supercomputer and holds all the world records in the popular MLPerf peer-reviewed benchmark. Let's talk about the journey. Today, every single company in IT has their CEO standing up and saying how they're working on AI and they're going to be the leader in AI. NVIDIA started in the early days of modern AI, going back to 2012. The so-called Big Bang of modern AI happened when a University of Toronto student, Alex Krusevsky, won a contest named ImageNet. ImageNet was a benchmark on classifying images out of a database of 1.2 million images. Now, if you look at the upper right, the amazing thing is not only did AlexNet, AI software written by an AI program, not by a human, won the contest, but the improvement rate over the years had been improving only 1 or 2% a year. And AlexNet came along and was 11% better than the previous year in classifying the images, won the contest, and caught the attention of the world's researchers in computer vision and in AI. By 2015, NVIDIA was far along in our journey of AI. At our GTC that year, we introduced the world's first integrated multi-GPU AI system. Even then, there was NVIDIA software as well as the hardware that was powering this system. The NVIDIA CUDA toolkit, NVIDIA's cuDNN, deep neural network software. At the time, cuDNN was embedded in the early deep learning frameworks that, unless you've been working in the field, you don't hear of anymore. Caffe, Theano, and Torch. But these systems that came out of universities went on to power and become today's deep learning frameworks such as PyTorch and TensorFlow that are synonymous with deep learning around the world. And to this day, still run on top of cuDNN and NVIDIA GPUs. In 2016, NVIDIA and our partners saw the rise of multi-node model training as researchers went beyond classification to new imaging problems like detection and segmentation. And we're starting to work on new topics such as translation, AI recommenders, and search. A single GPU or multiple GPUs in a server were not enough. It was in 2016 that we saw customers start to build full supercomputers for AI. The NVIDIA P100 GPU that we introduced that year broke a number of new technology breakthroughs. We introduced high-speed HBM2 GPU memory that is just now finding its way to other types of processors. And we introduced our NVLink GPU interconnect, a type of technology that today other vendors still have just in their roadmap. And to talk about the ecosystem, 2016 was the first year that Google's TensorFlow was released in beta mode. And of course, running on top of cuDNN, NVIDIA GPUs, and NVIDIA systems. 2016 was also when NVIDIA built our own first supercomputer for our engineers' use. We put together 128 of the then record-breaking DGX-1 systems. We used, at the time, the highest speed networking, Mellanox QDR 100 gigabit a second InfiniBand. Now today, 6 years later, 5 years later, many companies are just upgrading to 100 gig. But at 216, this was state-of-the-art technology. And when we put this system together, it ended up being ranked number 29 on the world's list of the top 500 supercomputers. But of course, NVIDIA engineers needed even more powerful systems, as did the systems of our customers. So we continued pushing forward. 2017, we introduced the NVIDIA V100, NVIDIA's first Tensor Core GPU. The beauty of building software as well as the hardware is we can fine-tune the two. We knew from our work in the software space that FP32, 32-bit math, was sometimes more than was needed for AI. So we introduced the first processor capable of hardware-level FP16, or 16-bit floating point. The mixed precision Tensor Core effectively handled multiple precisions at the same time. We enhanced our unified memory, making the system easier to program in standard languages. Could write in C, Fortran, other standard languages. And finally, to connect multiple GPUs together into one big GPU effectively, we introduced the second version of NVLink. At about the same time, here's what was going on in the software space. A number of researchers from Google published a seminal paper on the transformer deep neural network. The transformer was a new type of neural network, ushering in a new level of complexity that had never been seen before, but also opening up new possibilities, really starting to move AI from simple computer vision tasks to ever more powerful recommender systems and natural language processing and understanding systems. Again, we're only in 2021 today. This was only 4 years ago. And it's amazing how NVIDIA's been able to work with our partners in the ecosystem to move what was a research paper into the enterprise, into real world applications that are running today at world scale. At GTC in 2018, we introduced the DGX2, the world's largest GPU, so to say. 16 GPUs connected with NVLink. Of course, our researchers upgraded our supercomputer using the DGX2, as did Spur. Our system ranked number 20 on the top 500 list. And at the time, still a beta benchmark, MLPerf 0.5, we set another world record. Fast forward to last year, 2020. At our GTC, we were in the middle of the COVID lockdown, in the start of COVID. And if there's one thing that COVID has done, it's accelerated the computerization of machinery. People often talk about the fourth industrial revolution, and much of it is being driven by this computerization of machinery. Taking a simple robot, an automobile, a piece of farming equipment, and turning it from machinery to computerized machinery. In fact, today, people talk about supply chain disruptions to the IT industry due to COVID. And that has certainly happened. But the other challenge to the supply chain is the computerization of machinery. Everything, almost any consumer appliance, automobile, anything that you buy today has more and more computerization, more and more processing in it. And that's part of what supply chains have been struggling to respond to. But NVIDIA kept charging ahead. In the middle of our lockdown in the US of COVID, we brought up our latest NVIDIA A100 GPU. The A100 introduced a number of new features. Our multi-instance GPU let you take a single GPU and turn it into effectively 7 independent GPUs as seen by the operating system. This made it easy to use a single server for deep learning training at night, and during the day, use it on inference or other workloads where you needed smaller chunks of a GPU. To make it even easier to program, we introduced a new TF32 data format for automatic mixed precision. You know, they say that imitation is the best form of flattery. And it's been exciting to see other chip vendors announce new products now using NVIDIA's the TF32 data format invented by NVIDIA. In a deep neural network, not every part of the network needs to be computed. And so there's a technology called sparsity. And NVIDIA introduced hardware-based sparsity acceleration. Taking all of these hardware and software features together, with, of course, InfiniBand 200 gigabit per second networking, our supercomputer grew to be the number 5 system on the top 500 list when it was introduced. And even today, a year later, it's still number 6 on the top 500. And even more important, the DGX SuperPod is one of the most energy efficient supercomputers on the planet, holding a number of places on the top of the green 500 list of the world's most energy efficient supercomputers. And of course, turning to now the industry standard benchmark, MLPerf, NVIDIA continues to win every MLPerf benchmark. So if you're choosing DGX, you're in good company. Banks, hospitals, universities, in every industry, we see the DGX systems are being adopted. Let's talk a little bit about AI and some of the places where AI software is going. AI, of course, is not just about taking data and using an AI framework to train and turn it into a neural network. AI is a different type of software and is always learning, always evolving. That neural network, that output of the training step, that output of running on Christofari or one of our own top 500 supercomputers, that neural network is software. When you run that software can run on a much smaller computer. Any industry standard supercomputer from Dell, Atos, HPE, any of the other vendors supports NVIDIA GPUs. Running that neural network is called inference. And that inference can run all the way down to a small, low-power GPU in the device. And the device may be a PC, a self-driving car, a robot, a smart camera, or other device. And finally, that device generates more data. And you collect that data, save it, and send it back, retrain the network, and make the software better. This continuous process of AI learning is a journey NVIDIA's been on since 2012. Today, AI has absolutely moved out of research and into the enterprise. In public sector, in every industry, finance, and of course, in the internet, you see AI being applied. And even in traditional supercomputing, computing the laws of physics, we see researchers training deep neural networks to learn the laws of physics, being able to use a deep neural network with a traditional supercomputer simulation to speed up processing. We all hear every day about critical problems facing the world, understanding our climate and climate change, moving towards new renewable fuels and alternative energy sources. All of these require massive supercomputing power and haven't been problems we could solve before. The combination of AI plus traditional supercomputing is breaking new bounds in scientific research across the world. Now, let's talk a little bit in some of the NVIDIA software stacks that we commercialize and we make available through NGC, our software hub, where all of our software is placed and made available to the world. Besides running on large supercomputers in Spur's data center or in NVIDIA's, NVIDIA GPUs are available in every public cloud around the world, including, of course, the Spur cloud. And they're also available in enterprise data centers, either NVIDIA's own DGX system or through your favorite OEM. And finally, when your AI developers and data scientists go home at night, they're probably opening up a laptop powered by an NVIDIA GPU. And if they get tired of gaming and their kids aren't borrowing their laptop for gaming, they can do a little bit of work at night because, like NVIDIA engineers, they're so excited about the potential of their work that they want to be able to work any time of the day. And what's the output of that? Conversational AI, being able to not just give that traditional call center, hello, can you tell me what you want to do? And of course, most call center agents, chatbots, they don't work very well. So the first thing you say is agent or representative. Recommender systems. Anytime you buy something on the internet, your data is being processed by a recommender system. Recommender systems aren't just used in consumer systems. Recommender systems are powering different applications around the world. And of course, video conferencing. I'm coming to you today via video conference. And again, before the pandemic, very few people used video conference and used it sparingly. Today, many people live their lives on video conference. Cybersecurity couldn't be a more important problem to solve. If NVIDIA is going to be the world's leading AI computing company, we believe we need to be the world's leading and most secure computing company. And applying AI to cybersecurity is a perfect problem for NVIDIA to solve. Let's take a look at natural language processing. This started with Google's transformer model. Remember back earlier in the presentation, we showed the first research paper was printed in late 2017. And by 2018, there were already examples of that in the field. To give you some idea, The model size here is in billions of parameters. So the lowest one down, Elmo, about 100 million parameters. BERT Large came out in 2018 with 340 million parameters. And it's just kept going up. We've all heard about GPT-3 from OpenAI, which was previously one of the largest public models. And just a few weeks ago, NVIDIA and Microsoft released a new model we call Megatron Turing, 530 billion parameters. Think about it, from BERT Large to Megatron Turing. In less than 3 years, we've had a 1,000x increase in the number of parameters and the compute complexity needed to solve the problem. We simply can't put 1,000 times more servers in our data centers. These problems have to be addressed by not only faster hardware, but faster software. That combination of hardware working with software optimized together is what powers today's most powerful AI models. If you graph this, the speed of increase is amazing. The blue law down on the left, Moore's law, doubling of CPU speeds every 18 to 24 months. This really ended about a decade ago now, right as AlexNet was hit the market. Now, of course, we still see minor increases in CPU performance. But look at, if you graph all AI models, in 2 years, the average AI model has grown in complexity 25 times. And finally, the yellow curve, the most powerful AI models, are on a level of complexity where they're growing 275 times every 2 years. We don't know where this is going to stop, but I talk to researchers every day, and they tell me the more parameters we put in, the more powerful our AI models are, the better the accuracy, and the more types of jobs we can address. Around the world, we see AI pioneers using NVIDIA's DGX system. Of course, we're so proud of our work with Spur and multiple generations of DGX systems in the Cristofari supercomputer. There's another trend going on too. The CPU is an area where there hasn't been much innovation in the last decade. Moore's law has ended. There's only so much you can do. But with the emergence of ARM in the data center, and ARM-based data center CPUs, we see a new wave of architectural innovation around the world. Some companies are making their own ARM-based CPUs, like Amazon's Graviton, and even some countries in India, CDAC, the National Research Center, Fujitsu in Japan, ITRI in Korea, commercial companies like Ampere Computing, and in Russia, the Baikal ARM chip. NVIDIA, of course, has our own ARM chip, not to compete with the others, but our ARM chip is optimized to work with our GPU and solve giant scale AI and HPC problems. So as the complexity and the compute needs continue to grow 200, 300% every 2 years, NVIDIA Grace will be there to solve those problems. Of course, not all the AI is going to be in the data center. So much of the AI needs to be out on the edge. And this is where NVIDIA's solution, the same GPU, the same software, can run in your data center, can run in the cloud, and of course can run at the edge in all sorts of different industries. Now, we've heard a lot about avatars and how the new 3D internet may look. And I'm going to end with a little example. This is a demonstration based on our own NVIDIA cafeteria in one of those two shiny buildings you saw at the start. We call our cafeteria Shannon's, named after, and Shannon Shannon's is famous for those cheeseburgers. This demonstration shows how NVIDIA's AI technology will come together in Shannon's.
Hi, welcome to Shannon's Cafe. How can I help you?
I would like a cheeseburger with onion rings.
Would you be interested in our popular toppings for cheeseburger like bacon and fried onions?
Sure, add that.
Okay, I have added cheeseburger with bacon and fried onions to your cart. What else?
What protein options do you have?
We have multiple options. I recommend the double protein burger. Would you like that?
How is it made?
It is made from 2 beef patties.
Do you have a vegetarian option?
I can get you a black bean patty instead. Would you like that?
Sure, I'll try that.
Got it. Added double protein burger with toppings as black bean patty. Anything else?
What sides do you have?
So the video goes on for a bit more, but again, I've never had a double protein burger with 2 vegetable patties, but something I may have to try next time I'm in the office. NVIDIA's end-to-end ecosystem spans your AI journey. So thank you for joining me today for this short presentation that talked just about a few things that we're doing with Spur and other companies around the world. Thank you very much.